So what we are going to see in our CCNA new syllabus is, let's see the whole syllabus. Module 1, we are going to learn network fundamentals,
Okay.
where we are going to see the components and the roles of various network components,
Mm-hmm.
and then the cabling, infrastructure, so on.
Okay.
We'll talk about the collision domain, broadcast domain, some common
Mm-hmm.
errors, a duplex, mismatch, speed, all those stuff.
Mm-hmm.
Then
Mm-hmm.
we'll be learning OSI reference model, in which we will be
Okay.
comparing the TCP UDP differences. All right,
Yeah.
so in Cisco they have not mentioned it, but it is very important. OSI, the whole OSI model,
Mm-hmm.
in which we will also see this thing, UDP and TCP
Okay.
differences. And then we will
Mm.
have IPv4
Okay.
addressing, also IPv6 addressing. And in
Okay.
IPv4, we will learn subnetting. And then
Mm-hmm.
different address types that we have in IPv6. Like you have in IPv4, private address, public address. Even in IPv6, we have some sort of address type. We don't have private
Mm-hmm.
address, but we have some addresses like link local address, global unicast
Yeah.
address, multicast address,
Mm-hmm.
anycast, so on. We'll be discussing all those things. And
Yeah.
then this is for the beginners, how to verify the IP address in Windows, Linux. Some people they even don't know this thing, so we'll see those things, like how to give IP address to a Windows computer and how to go to the
Mm-hmm.
command line and verify that. Well, for you, it may not be a problem. And then wireless principles. There's a separate track called wireless in Cisco, but here we are going to learn introduction to wireless.
Okay.
And then
Mm-hmm.
introduction to virtualization. We also have a separate track for virtualization, but here we will, I'll explain you the virtualization fundamentals for you.
Okay.
Then we'll
Okay.
also get into switching concepts. Again, those things will be elaborated in coming module. In the next module, if you see the switching concepts, it is elaborated. That is an access
Mm-hmm.
layer. Switching is the access layer where we have VLANs, inter VLAN routing, inter switch connectivity, which is nothing but trunk links, Ether channel,
Mm-hmm.
RSTP, which is a loop prevention mechanism. And then this wireless principle that you learned here again, it is elaborated a little bit more. Yeah. So
Okay.
that's
Okay.
module 2. And then in IP connectivity, we'll be learning IPv6. We already learned about. Now we are getting into the routing perspective of IPv4 and IPv6, where we learn
Mm-hmm.
IPv6 and IPv4 static routing and default routing, OSPF version 2, and then FHRP, first hop redundancy protocol. To be more
Mm-hmm.
precise, it is going to be HSR. All right. And then, but you're learning Nexus later, so I'll also include here VRRP, which is not in
Mm-hmm.
CCNA,
Okay.
but I'm going to include so that Nexus we have VRRP support, so you should know here.
Yeah. Mm-hmm.
Um, and then followed by IP services where we have NATing, different type of NATing, static NAT, dynamic NAT overload,
Mm-hmm.
DHCP, SNMP, syslog, a little bit of QoS introduction here, and then
Okay.
configuring SSH on a Cisco router, TFTP for file transfer. We'll discuss all those things. And
Mm-hmm.
then the last module will be security fundamentals, where we focus more on security, but there is a separate track for security. Here, we are learning the
Mm-hmm.
fundamentals of security, in which more emphasis is given to the site-to-site VPN using IPsec. We'll also learn, all
Okay.
other topics to a fundamental level. All right. So this is what we are going to
Mm-hmm.
cover in our CCNA. So
Okay.
we'll try to push as soon as possible. We'll try to go through as fast as possible, but at the same time, fast is not good. We need to learn and then
Mm-hmm.
we need to finish. So, whenever you see some topics more comfortable, you may say to me so that
Mm-hmm.
we can go a bit faster. Uh, on the
Yes.
other topics, we'll spend a little bit extra. Yeah.
Okay. Okay.
So, do you have anything to ask before we start first module?
uh, so this is part of CCNA and data center
That
will
is
be a
different. That
different
is different. We have to finish this first.
separate. No,
Yes.
okay. Okay. Yes. 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 Yeah. Yes. Yes. Arun sir. Like I think this is good
All
actually.
right.
I mean, some of the topics, as you told, I am also familiar
Yeah,
because when I
I
am
know.
working with data center networking, some of the topics we are
Aware
already
of.
covering. So those topics we can move
Yeah.
fast. And other topics, as you told, some of the topics which I am not very much hands-on or not very much familiar in concept-wise,
Yeah.
there we can spend some more time,
Yeah.
sir.
Yeah.
Right?
Yes.
Okay.
Sure.
Yes. Yes. Yeah. Let's
Let's
get
start
started.
with the module one. Module one, let's focus on the very first topic. Explain the role and functions of network components. This is not new to you.
Mm-hmm.
This is a well-known topic. Um,
Yes.
so let's keep it a little bit fast-paced, because it's a known topic to you.
Yeah.
Now, when we talk about network, what is network? It's the medium through which we communicate
Yes.
to nearby device or remote device. It depends. We mainly use for communication. Instead of we opening our
Mm-hmm.
mouth and talking to someone, we would like to drop a mail so that whenever that someone is free, he can open the mail and know the message. So communication makes the transfer of information faster and in a more of
Mm-hmm.
in our own flexible time. We can access the
Mm-hmm.
data. Communication through network makes it easier. Even now, we are doing communication. It's a live streaming audio and video that we are having. I really do not know which part of the world you are in. I'm in Bangalore. You are able to hear me very well, as if
Yeah.
I
Yes. Yes.
sit.
I'm in Bangalore
Okay,
only,
you're
sir.
also in Bangalore. Fine, but we are not near. We are at least few kilometers away, but still, we can able to hear very well.
Yes.
You can see my
Mm-hmm.
screen. I'm saying welcome. You can see my writings. It's all because of networking. The purpose of networking is not only just to send mail, receive mail, send some data, documents. Not just like that. We can also do video, audio conferencing. We can transfer money. We can transfer bitcoins. A lot of things have come now today. Depending on networking, we survive. People order food. It is all because of networking. No, they don't call anyone, but food comes just by using some apps. You type in, you punch in, and the food comes to your home. You never rang any number to a restaurant asking for food or some networking. So, networking has become a part of human life today. And this networking is not just by using one wire or one device. The various devices contributes networking.
Yes. Yes.
We got
Mm-hmm.
various devices. If I need to start from the beginning days, then I should start with something called amplifier.
Mm-hmm.
But the amplifier is no more, as the word says, amplify. It is going to amplify the weak signal. That's the purpose of amplifier.
Mm.
If the wire can carry, for example, I'm writing if the wire can carry 100 meter only, let's say, there are cables which can carry 1 kilometer more than that, but I'm just writing. For example, there is a cable which can carry data of only 100 meter. So if the destination is in 200 meter, definitely you need someone to boost the signal, because the
Yeah.
signal will get weaker as it travels more far. So we keep one box here in the middle so that when the signal is getting weaker, it will boost up again, so that the receiver will get the sound signal, strong signal. That is what amplifier is. But there was a drawback in amplifier. What was it? Amplifier amplifies whatever comes inside. So this is the data, but on the way, because of some electromagnetic force and the ground gravity force, some additional, I can say, as data, but it's not a data that we sent. It's some additional data. We call it as noise that got added in the path, and even the noise will get amplified. That's the problem with the amplifier. The noise gets amplified, but it's only the data that was sent here. But when receiving, he is receiving along with some green data, which is because of some magnetic force, the geo force. So we need a clever device which can identify this noise and filter that noise. So came a repeater. The repeaters are same like same like amplifier. The difference is they are very clever. They filter the noise and amplifies only, regenerates only the data. So the repeater was more smarter, but again there's a problem. So we don't use a repeater. Why? Because the repeaters are very small, like they cannot support more than two devices. The number of ports in a repeater is only two, because they cannot handle more than two uh, device traffic. More traffic, repeater.
Sorry, sorry to disturb. Like repeater is for like for issue, and I mean if any fault happened during the traffic, to understand that issue, we have repeater.
No. That is different device. That is tapping device. That is
Okay.
tapping device where we tap and we take traffic and we examine the traffic using some Wireshark or something. That is different. I'm not talking about tap device. For tapping, yeah, something similar to repeater we have today, but that is not repeater. That's tapping switch.
So what is the purpose of repeater, sir?
Again,
Can
it
you explain
regenerates
that?
the signal. You see, the
Okay,
weaker
got it.
signal got regenerated.
Okay. Only weaker signals
Yeah,
it will
it won't
regenerate, correct?
regenerate the noise. So repeaters are
Correct, got it.
clever to identify the noise and filter the noise. Whereas amplifier is a dumb box, whatever comes in, it will amplify. But the drawback of repeater is repeater has got only two ports. But when I want to
Yeah.
connect more than two devices, um, 100 meter, 100 meter, 80 meter. So if I want to have a repeater cannot support me, because repeater can only connect two devices. Third device, where will I connect? I don't have an option. So there came another repeater, but we don't call it as repeater. It is called as hub. Hub is a multi-port repeater.
Okay.
Multi-port. Multi-port repeater is what we call it as hub. So
Okay.
repeater hub. Difference is repeater is just 2 ports. Hub, you will have maximum of 8 ports only. There is no more,
Okay.
only 8 ports. All right.
Hub means like it will
Regenerate the signal.
it will get
It will
regenerate all the time.
regenerate
Yeah.
the signal between a maximum of 8 devices.
Okay.
Not
Okay.
more than that. Maximum of 8 devices.
So it will get data in one port and
Yeah.
it will
It will
detect the noise and regenerate the weak
to
signal
all other 7
and
ports.
send to other port.
Yeah.
Okay. Okay.
Yeah. Now you already saw the drawback of hub. You just told me the drawback of hub. Drawback of hub is
Yeah. It's copy.
it gets signal from one port and it will flood it to all other ports. That's a
Yes.
drawback. Why it's a drawback?
Correct.
Because we are not willing to send. See, A wants to talk to C, but the traffic will even go to B. That's the problem with the hub. Hub will always broadcast, always.
Correct. Mm-hmm.
So this is a drawback which needs to be rectified. So why it is always broadcasting? For that, we need to understand another topic from the list called where is that? Collisions. All right. I'm going to talk about this for some time. Okay, to understand why hub always broadcast. Why hub has got only
Okay.
8 ports? There are connection. Why it is only 8 port? It is only 8 port maximum.
Yeah.
It
Correct.
is because it always broadcasts. Okay, why it is always broadcasting? Because it has got only one domain for controlling the collision as well as one domain for controlling the broadcast. So you see, how can we avoid collusion if see, for example, there are 3 children at home, let's say. If 3 children should not fight, what you should do, you need to buy 3 pen. If you only buy 1 pen, then 3 children will fight for that pen.
Correct. Correct.
That is the problem. You see, to control the collusion, there is only one domain. There is only one controller for the entire box. For the entire
Okay.
box, there is only one controller to control the collusion. Then there will
What does that mean? Like only one
correct
hardware only,
inside
or so like controller means one
inside
hardware. Okay.
the setup, the architecture, the program, the program and the hardware
Yeah.
architecture is having only one in order to control all connected device.
Okay. Okay.
Just one single program that needs to control the traffic coming on every port. You don't have, in another word, if I need to say, you don't have separate controller.
Understood.
You don't have separate controller. As a result, the collision happens. As I said, if you have only one pen for 3 children, there is going to be collision for that pen. He also one pen, that guy also one pen, this guy also one pen. Likewise, if A is sending traffic, because there is no separate dedicated path for A to reach B, because there is no separate dedicated path to reach B, all will try to share the same path. For everyone,
I understood. So here
your
pen.
pen is the path.
path.
For
Yes.
everyone, if you have separate path, then they will not collide. They won't form collision. There won't be a traffic jam.
Mm-hmm.
If everyone uses
Mm-hmm.
the same road in the morning, collision.
Mm-hmm.
If everyone have got separate road to go to office, no problem, no,
Yeah.
no problem,
Yeah.
no
Correct.
traffic jam. You see, that is the problem with the hub. Hub has got something like this. For your understanding, I'm drawing. You might have heard about bus topology in your college days or somewhere. You might have learned
Yeah.
bus topology. You see, for all these four computers,
Mm-hmm.
the backbone is only one, isn't it?
Yeah.
There's only
Yeah.
one
Yeah.
backbone. For all these four computers, there is only one backbone. As a result, there is going to be a collision if all talks at the same time. Correct?
Mm-hmm.
So,
Yeah.
if you have more computers, this
More
this will
traffic.
not
Mm-hmm.
tolerate the traffic and no traffic moves. See, in a road, if there is a if there is four road, one vehicle is coming here, one vehicle, no problem. You know, you will adjust and you will go. You will adjust and you will go. But if
Mm-hmm.
this is keep on coming, this also keep on pouring, keep
Yes.
on coming, no one will move. No, full collision. No one can move.
Mm-hmm.
Traffic jam. Only someone in a helicopter
Correct.
need to come down and clear the traffic. Not possible. Sometime you might have seen this in Bangalore junctions. You will be keep on standing. No one will
Yeah.
move like
Mm.
this. If you have more than 8 port, then you will have more computer. 8 port, 8 computer.
Correct.
For 8 computer
Mm-hmm.
traffic, this can manage. This can tolerate
Mm-hmm.
with one backbone. If you have more than
Mm-hmm.
8, difficult for everyone. So no one
Mm-hmm.
can communicate if you have more. So
Mm-hmm.
hub is limited to 8 ports. If you have more, the controller cannot control because there is only one
Handle.
controller. Because there is only one controller. Controller cannot control.
Sir, it's a
Hardware,
hardware
hardware,
limitation that
hardware
because of.
limitation,
Mm-hmm. Mm-hmm.
architecture.
Mm-hmm.
Right. So this
Mm-hmm.
one, for your understanding, I have drawn this. You are not really seeing that
Mm-hmm.
inside. You will see one motherboard.
Mm-hmm.
But motherboard
Correct.
architecture is like this.
Understood.
So there is no separate chipset to control traffic between these two,
Mm-hmm.
these two, these two, these two. There is no separate path. There is only one path. There is
Mm-hmm.
only one chipset. Only one controller to control
Mm-hmm.
traffic coming from all devices. That is what here it means.
Mm-hmm.
One control, one collision device domain. Meaning
Mm-hmm.
one collision controller. Only one collision controller.
Mm-hmm.
Only one
Mm-hmm.
backbone, only one collision controller. As a result, you cannot connect more devices. So they decided not to have more than 8 ports. Because hub, according to the standard,
Mm-hmm.
the architecture is not capable of carrying more traffic from more device.
Mm-hmm.
Because architecture standard
Mm-hmm.
says only one collision domain for a hub. Not only
Mm-hmm.
that, if someone
Yeah.
wants to send broadcast, what is broadcast? Sending to everyone. They will use that
Mm-hmm.
same backbone, which is also
Yeah.
controlling the collision. It's the same backbone which is also going to be used to go to everyone, which is called broadcast. So you got only one
Mm-hmm.
collision domain and one broadcast domain in hub. As a result,
Mm-hmm.
you need to always broadcast because there is no separate path to reach from A to C, isn't it? So you have to always broadcast because there is
Correct.
only one common backbone. Anything touches this backbone goes to everyone. That is why it is always broadcast. See, everything is
Okay.
interconnected. Why it is 8-port? Because you got only one collision domain. If you have more than eight ports, more device you will connect, then the architecture cannot support, because there is no controller, only one controller. Not only that, if you want to send to everyone, it is the same one controller which is also taking the traffic to everyone. So there is only one backbone.
Yeah.
For this backbone story, I am telling you for your understanding. It's not real backbone. The architecture is like that. So
I
there is only
understand.
one
Yes.
collision
Correct.
domain and one broadcast domain. As a result, hub cannot support large network. Two reasons.
So
One
this,
is
so this, okay, sorry, this bus architecture you
yes,
mentioned, no? So that is just
your
for
understanding.
my understanding, correct?
But
The
truth is,
okay, okay,
internally, the logical architecture is similar to bus architecture. The motherboard architecture
okay,
is somewhat
okay.
similar to, but physically you cannot see. Okay, it's logically bus topology. Yes, logically it is inside bus only, but you will not see in that motherboard. It will be just one green motherboard. That's all, green or brown color motherboard. Okay, so now let me repeat again. Hub can support only 8-port. The reason is it has got only one controller to control collision. More than 8 device, traffic cannot be controlled. And also, it's the same reason why you have only one broadcast domain. Because you just got only 8 ports and all share one common backbone. It's the same backbone you will be using to reach everyone. So if only one backbone for everyone, so there is no separate path, always broadcast. So only if you have separate path, you no need to broadcast. See, uh, if I don't have a dedicated phone number to reach my team member, if I have only walkie-talkie, I have no other option. I have to always broadcast, right? I don't. Let's say no one have got
Correct,
cell phone
correct.
in our team. We are 10 members in a team, and we all got only walkie-talkie. How can you talk to Mr. Raj? You cannot talk to Raj because he don't have phone. You
Yeah.
have to use the walkie-talkie. When you use the walkie-talkie, everyone is going to listen.
Yes.
Yeah, hub is like on walkie-talkie. There is no dedicated phone number, but you can talk to everyone. You can also talk to one single
Yeah.
person, but everyone will hear. Message can be conveyed to one person, but it's not safe. No, everyone is hearing. You cannot have any private talk. So hub is dangerous because it will always broadcast. Because of this reason, one collision domain, one broadcast domain. Fine. So we learned the drawback of hub. So what is the alternate? If hub is not safe, if hub will always broadcast, if hub is not scalable, it supports only 8 devices. What is the option? Okay, they come with another option called a bridge. Bridge. Okay, what is the difference between hub and repeater? Repeater is just 2-port. Hub is multi-port, isn't it? What is the difference
Multi-port, yes.
between amplifier and
Yeah.
repeater? Amplifier amplifies even the noise, whereas repeater
No, it's
regenerates
correct.
only the data. And now we are into fourth device. This is fourth device, right? Amplifier, repeater, hub. Now this is fourth device.
Repeater
This is the
hub.
fourth device. Bridge. What is bridge? Bridge is a smart device.
Smart. Okay.
There is some smartness in bridge. As a result, you will have more collision domain.
More collision domains means
More
more
dedicated path.
paths,
Very
right?
good. Very good.
Individual
Very good. You got it.
dedicated paths. Yes.
You got it very clear.
Mm-hmm.
Bridge, I have seen, up to 25 ports, not more than that again.
Mm-hmm.
Now, this bridge, the bridge is a smart
Mm-hmm.
device. If there is 25
Mm-hmm.
port, then you will have 25 port will have 25 collision domain,
Mm-hmm.
meaning each port will have a collision domain.
Yes.
So you no need to broadcast every time to everyone. It is like
Mm-hmm.
having phone number for everyone. See, you are
Yes, correct.
the you are
Mm-hmm.
the you are the wing commander in Indian Air Force, and you have some 10
Mm-hmm.
Jawans under you. Now,
Mm-hmm.
everyone have got walkie-talkie, and everyone have got
Yes.
also a phone. So whenever you
Mm-hmm.
want to talk to everyone, what you will do? You will take walkie-talkie. Same.
Walkie-talkie, yes.
Switches have got one broadcast domain.
Broadcast domain. Mm-hmm. So they can't, I mean,
Now, if you
so why individual path is not
see
required
what is
for
broadcast,
broadcasting?
broadcasting is
Okay.
you sending to everyone, right? If
Okay.
you will send an
Yes, yes.
individual path, then you need to spend 25 times more processor instead of
Mm-hmm.
calling through walkie-talkie. If you need to call 25 people, then
Mm-hmm.
you need to dial 25 numbers.
Yes,
25
yes, correct.
numbers you need to dial, and 25 different phone number. Here in our case, 25 different IP address, something like that. It's going to be too much processor.
Understood.
So
Yes.
whenever you want to send to everyone some message, you will use
Mm-hmm.
this broadcast domain. But whenever you want to talk to an individual person, which was not possible in the hub.
Mm-hmm.
Why? Because hub has got only one collision
Mm-hmm.
domain, common for everyone. It
Okay.
is like a Bangalore road. Everyone shares
Mm-hmm.
one road.
Road, yes.
But bridge is like everyone have got a private road. Or in another word, everyone has got a cell
Mm-hmm.
phone.
Cell
You
phone, yes.
can even use cell phone. You can also use walkie-talkie. Whenever you want to talk to a particular person, you don't need to use walkie-talkie. You just call the
Mm-hmm.
number. In that way, you don't
Mm-hmm.
unnecessarily disturb others. You don't collide, isn't it?
Mm.
That is why
Yes.
you call collision domain, because it's not going to form collusion. It's not going to collide with other data. Whenever you are talking to one
Mm-hmm.
person, others are not getting disturbed. Others are doing their own job. You have 10 members in your team. You
Mm-hmm.
are calling
Yes.
Ravi. When you are calling Ravi, will money get disturbed?
Mm-hmm.
No, no. When
Yes.
you are calling Ravi, will
No.
money get disturbed?
Uh,
No. Will
no.
Jacob get disturbed? No.
No.
Only when
Mm-hmm.
you do broadcast, everyone will get disturbed.
Mm. Yes, yes,
Actually, you
correct.
want to talk to Jacob, but because you are doing broadcast, everyone get disturbed, and only Jacob
Mm-hmm.
will be responding. You others, they are getting disturbed unnecessarily. They're not going to respond, but they unnecessarily
Mm-hmm.
got disturbed. They are listening to you, isn't it? Yeah.
Yes, yes.
So what we need to do is we need to replace all the hub to bridge. That's what they did actually. There is no more hub nowadays. You don't
Mm-hmm.
see hub. We got
Mm-hmm.
bridge. Bridge is a soft, smart device. Bridge is a smart device
Mm-hmm.
because it has got 25 collision domain. What does that
Mm-hmm.
really means? What does that really means? You already understood one side of it. You say it is like
Yeah.
having a dedicated road. It is like having a
Yes.
dedicated phone number.
Dedicated path.
It is like having a dedicated path. That is right.
Mm-hmm.
But how it is achieved is what we are going to see.
Yes.
Now, when you see
Mm-hmm.
bridge, when you see a bridge, you will have a chip
Mm-hmm.
on each port, which is not there
Mm-hmm.
in a hub.
Hub. Hub, it is only one chip
Correct.
to handle
Now,
everything. Like. Mm-hmm.
this chip here is capable of learning the connected device MAC address. For your understanding, I'm writing AAA, BBB, CCC. Assume it as MAC address. MAC
Mm-hmm.
address is 48-bit size. I don't want to write a big MAC address, wasting time. So I'm making it simple.
Mm-hmm. Mm-hmm. Mm-hmm.
So we got 5 computers connected. Now,
Mm-hmm.
the MAC addresses of this P1 port, P2 port, P3, P4, P5. So
Mm-hmm.
they are maintained in a table called MAC table. So this
Yes.
MAC table will say port 1 A is connected, port 2 BBB is
Mm-hmm.
connected, port
Is
3
connected. Mm-hmm.
CCC is connected, port 4 DDD is connected, likewise port 5. So
Mm-hmm.
they maintain. Now, if A wants to talk to D, when packet arrives, it knows where is D. Where is D? It is in P4, isn't it? So it takes a
Yeah.
dedicated path. In the hub, there was no
Yeah.
learning.
Correct.
In the hub, there is no learning, no
Mm-hmm.
chip for learning MAC address. As a result, always
Mm-hmm.
broadcast and collusion. Here,
Broadcast. Yes.
because they know where is who, they take a dedicated path. To support
Mm-hmm.
this dedicated path, the architecture is also there, physical architecture. So once the MAC address is learned,
Mm-hmm.
and when
Yeah.
it knows the location, it pushes the packet only to that location, not to everyone. As a result, there is no
Mm-hmm.
collusion. When there is no
Yes.
collusion, you can handle more traffic, isn't it? Yes.
Yeah.
See, whenever
So additionally, sir, like this I mean, this particular bridge, it having that intelligence to learn the MAC address from the
right,
packets, correct? Then only
yes,
it can
correct. When the
prepare the
packet
table.
enters, when the packet
Mm-hmm.
enters, the source MAC address
Mm-hmm.
is learned. The source MAC address
Yeah.
is learned into the
Mm.
MAC table. All
Yes.
right. Okay. Here you go. So the
Yes. Yes.
bridges are smart device. Now,
Mm-hmm.
why it is smart device? It learns MAC
Yeah.
address. Now, from where it learns MAC address? As you
Yes.
said
Yes.
earlier, you're right. It learns from the incoming frame source MAC address. So it learns MAC address from the incoming frame. What does it mean? Incoming packet. For example, if this A computer is talking to C computer, the packet will be like this. Source MAC address is AAA. Destination MAC address is CCC. When this packet approaches a
Mm-hmm.
port from the source,
Mm-hmm.
it learns that on P1, A is connected. Earlier, it was blank.
Mm-hmm.
MAC table
Yeah.
was blank. Now it learns A,
Mm.
and one. And then, because the destination is unknown, listen carefully, this is important. Because the destination is unknown, do you have any information about CCC? No. If the destination is unknown, for unknown destinations, switches will flood. It learns from incoming source back. It learns MAC address from incoming source. But the destination is not known initially. It will flood the traffic. So, what is the rule? When destination is unknown, what do you need to do? Flood it. Flood the packet. How it will flood? By using that one broadcast domain. Yeah, there is one controller which can take traffic to everyone.
Mm. Yeah.
So it will flood, it will go to
Yes.
everyone, including this guy. Now, when this B receives the packet, it will check the destination. It is not matching with the local MAC address, so it will drop. It won't process further. C will process it.
Mm-hmm.
D will drop it.
Mm-hmm.
E also will drop it. Why? Because the destination is unknown.
Mm-hmm.
Destination doesn't match.
Unknown. Yeah.
Only C will respond back. So how will be the C response packet? C will say, I am talking, it's me, CCC. To whom it is responding? To the one who sent it. Who sent the packet? Who sent the packet to C? A. Yeah. So that becomes the
That's
destination.
A send the packet.
Now,
Yeah.
when this packet approaches this port, it learns from the source that CCC is connected. And now it wants to forward the packet to AAA because there is an entry already there saying AAA is connected to P1. It will not use the broadcast domain. It will use its own collision domain to go here. In this way, once the MAC address is learned, no more broadcast.
Yeah.
Total collision is controlled. Because there is no collision, there is no flooding, the process utilization is going to be less. As a result, this device is having enough of processor to handle more traffic. That is why you can see in bridge, you can have up to 25 devices. Whereas hub is only 8 port.
Yes.
Because it cannot handle. But this can handle because there is a broadcast domain and collision domain, separate collision domain for each port. There is no collision at all. As a result, the processors are free, having enough resource to handle more traffics. Okay, now.
So one question here, no? Like, see, we have one bridge here, and then if you are taking two bridges, and one port of one bridge is connected to another port of another bridge.
I understand
then
your question.
In bridge one, we connected one.
We will discuss all those things here. You know that's in next module. We are simply trying to understand
Okay, got it.
different network components and the roles. And this topic is very important to understand this, so I brought it inside. All right. We are partially learning switching concepts. Partially. What is that? You just learned that they learn MAC address as the traffic comes in. From where it learns from the source. And if the destination is unknown, what it will do? It will flood. Okay. Now,
Flood.
listen please,
Mm.
here we are learning bridge. This has got a drawback. What? Only 24
Mm-hmm.
port. So, what
Mm-hmm.
if I have 100 port? I need something big. What if I have 100 device? I need a 100
Mm.
port switch.
100 device, yes. Mm.
We cannot keep connecting bridges as you were trying to ask me question. I said later we'll discuss. That's not a good idea.
Yeah. Mm-hmm.
See,
Mm-hmm.
okay, so instead of let's say one child can carry only 2 kg. It's like a bridge, only 2 kg. Now,
Mm-hmm.
if you keep adding more children
Mm-hmm.
because you want to carry 10 kg of rice, then you will add how many children? 5 children.
Mm-hmm.
5 children
Mm-hmm. Yeah.
managing is not easy. So you need
Yes.
one
Got it.
guy who can carry all 10 kg. Connecting more bridges is not a good
Yes.
idea. Let me put it in a better way.
Mm-hmm.
You
Got it.
see, this
Mm-hmm.
and this, which one is good? See this, let's say this can accommodate 10 kg. This is 5 kg each. Now let us come to technical side.
Mm-hmm.
Switches, you are going to connect
Mm-hmm.
this with one wire. But here, a motherboard,
Mm-hmm.
which is going to be faster.
Mm-hmm.
Processing in motherboard is faster. Here, this 5, if it wants to talk to other 5, it needs to go through a bottleneck,
Mm-hmm.
isn't it? Whereas here,
Yeah,
it will be
correct.
more faster in a motherboard speed.
Mm-hmm.
So,
Faster. Yes.
we want something
Yes.
big. That is why switches came.
So
Yes.
bridge and switch
Wait,
both are
I'm coming
different,
to the
you are
point.
saying?
Bridge
Uh,
and
okay.
switch
Mm-hmm.
are
Mm-hmm.
different, and also they are same in another way. In which way it is same? Bridge also learns from the incoming frame's source MAC address. Switch also learns like this, bridge also learns like this. Switch also will flood, bridge also will flood if
Mm-hmm.
the destination is not known. But switches, if you take, you might have seen 12 port
Mm-hmm.
switch, you might have seen 48 port switch, you might have seen 24 port switch, you might have seen 100 port switch, 300 port switch. Switches coming.
So basic
Yeah, I'm
difference
going to
between
come
switch
there.
and bridge, like switch having more
I'm
power.
trying to
Mm-hmm.
say
Yeah, yeah.
how it is same,
Mm-hmm.
and later I'll say how it is different. Now I'm trying to say it is same because they both have collision domain more number and one broadcast domain.
Mm-hmm.
If I have 300 port, how many
Okay.
collision
Okay.
domain? 300 collision domain. So every port on a bridge is
300
also
collision
having a
domain. Yes.
collision domain like switch. Both bridge and switch have got this as
Mm-hmm.
similarity. But the difference is, I was telling you,
Mm-hmm.
no, in in bridge, every port has got a chip, isn't it? To learn the MAC address,
Yeah.
but it is not real chip.
Mm-hmm.
In bridge, it is not real chip. It is just one buffer.
Okay.
But in the switches, they are
Okay.
real
Okay.
chips.
Mm-hmm.
The chip is called as ASIC
Okay.
chip.
Okay.
This
Okay.
is the big difference because it's a ASIC chip, because it's a
Mm-hmm.
hardware.
So which?
It can
Uh-huh.
it can learn more MAC
Yeah.
address. It is like you have a see, if you have a bridge, it is only one processor for the motherboard, and all these buffers are controlled by that one processor and the program. But when you have switch,
Mm-hmm.
these are real chips equal to processors.
Mm-hmm.
So bridge has got only one
Mm-hmm.
processor.
Yeah.
Switch has got more additional processors like sub-processors,
Mm-hmm.
physical components. That is why
Yeah. Correct.
switches are
Uh-huh.
called as hardware-based device, whereas bridge is called a software-based device.
Mm-hmm.
They work in the same manner, but this is software-based
Okay.
device
Okay.
because the operating system maintains this buffer. Operating system makes this learning, listening, everything. But here, the real hardware is sitting on
Mm-hmm.
each port, listening and learning the MAC addresses.
Mm-hmm. Mm-hmm.
And
Mm-hmm. But sir, one question, like in
same job,
but the
but
activity they
it
are
is
doing same
like
only, right?
only one person in the
Same.
office
Mm-hmm.
to do front office
Mm-hmm.
job, HR job, CEO job, employee, employer, everything is that one person. Bridge.
Mm-hmm.
Switch is like you
Mm-hmm.
got a CEO,
Mm-hmm.
you got a director, you got a dedicated HR, you got dedicated front office, you got
Mm-hmm.
dedicated, everyone dedicated. As a result, your business is going to be more faster because you got
Mm-hmm.
more people to think and share the load, isn't it? Because you got more chip, more
Mm-hmm.
hardware,
Mm-hmm. Yeah.
this can handle more traffic, not just one processor getting skewed. In bridge, it is one processor getting skewed.
Mm-hmm.
As a result, it cannot handle too much traffic. So they have put 25 as the upper limit. Whereas here, there is no limit.
Mm-hmm.
If you
Yeah.
have more chipset, more number of ports, more
Mm-hmm.
amount of traffic, more throughput. See, there are some switches which is of TBs of throughput. TBs of throughput. The motherboard can have TBs of throughput.
Mm-hmm.
TBs in gigabits. So
Mm-hmm.
throughput, that amount of traffic it
Throughput
can
means
gulp it and
like
process it and send it out. Incoming, it can handle too
okay,
much
okay.
in
So
TBs of
coming.
data can come at the same time inside, get processed same time and sent out same time.
Mm-hmm. Okay. So throughput
Yeah,
means like a
capacity of
T
a switch.
transmit plus
It's not
receive
just
packet
port.
per
You are
second,
saying
like that.
transmit and receive, which is only a one
Okay.
port.
Okay.
I'm saying for the entire switch that transmit and receive.
Mm-hmm.
See, when you receive, you just don't simply
Okay. Got it.
transmit. You need to process. You need to think which port I need to send. These are all switching job. You know? All this will happen for TBs of data.
Mm-hmm.
More capable. So more chipsets,
Mm-hmm.
more
Yeah.
capable, more ASIC, more capable. That is why
Mm-hmm.
switches are supporting big number of ports. Basically,
Mm-hmm.
they work both in same way. Bridge
Yeah.
learning MAC address. Bridge is a smart device. Switch is also a smart device. Switch also learns MAC address same way like a bridge. When there is no destination information in the MAC table, both
Mm-hmm.
flood the packet. This all happens same way, but the big difference is
Mm-hmm.
switch is a hardware-based device. Bridge is or software-based device, because it's only one processor and one operating system need to take care of all the jobs in the bridge, so it cannot handle more traffic. So it's a small device. It's a small switch. Bridge is a small switch. So the hardware version of bridge, meaning all the functionality what the software was doing, is here now in the hardware. See, if you go like 30 years back, no, 30 years back, let's say 40 years back, you were having only watch, which was uh, like you need to dial it. You need to It is not using electronics. HMT watch was one famous on those days. HMT. Have you heard about HMT? Yeah, HMT watches. So there is no battery in it. You need to dial it.
Yeah, yeah.
You need to give key, make the spring tension inside. That
Correct.
tension, the spring will make the dial to run. But now it is software based. Earlier it was hardware based. Now it is software based. Open the watch and see. Now you will have one motherboard and one battery. Yeah. So it's a software based example. So, but here in our example here, switches are hardware based. Hardware based can handle more amount of traffic because there's more hardware, not just one processor. There's more chipsets, ASICs, to share the load.
Hardware.
All right. So these are the differences. Same like bridge, switch also have got n number of collision domain, where n stands for number of ports. If I have a 24 port switch, then I have 24 collision domain. All right. 48 port switch, 48 collision domain, but only one broadcast domain. Now let's go to the next device called router. Router is another network component, very important to connect between different networks. So switches are not capable of connecting between different networks. You need router. So different network communication is only through router.
So
There is no limit actually.
yeah, what is the
Daily it grows.
limitation of switch then? Like
Daily it grows.
No, this switch, no, like switch cannot connect to two different
Okay, you
networks,
can
right?
say like that because they don't
So that
understand
what is the
IP
reason
address.
behind?
Different network means what? Different IP address, different class of IP address. A computer in 10.0.0.1, another computer in 20.0.0.1, they cannot talk. With a switch, they cannot talk. They need a router. Router we draw like this one just big round you put, that's all, router. Switch you put one rectangle, that's enough. You can also say if you want like this, you can also put like this. This is a router. So a router is to connect between two different networks. Switches, they all need to be in same network. Bridges also same thing. All need to be in same network. Hub, everything what you learned so far before router is same network device. Here also 10.0.0.1, 10.0.0.2, 10.0.0.3, all 10 network it should be. Otherwise they cannot communicate. 10.0.0.4. So amplifier, repeater, hub, bridge, switch, all same network.
So one question, sir, like for example, in one port I connected one host, correct? For a switch now, in one port I connected one host with one IP, which is in one subnet, and in second port I connected a host in a different IP address. Means why? I mean, what will happen? That packet come to switch.
The MAC address here is AAA. The MAC address here is BBB. See what will happen when you go to this computer and try pinging to generate traffic. We will ping, okay? Ping 10.0.0.2. Sorry, 20. different network, right? 20.
Yeah.
This PC will not first of all send the packet out.
Yeah.
It won't go out. Why? For the PC to send the packet, it needs router's address, because every operating system is developed as per the standard. That is why we give default gateway. What is default gateway? That is the address of router.
Got it.
On every PC, we give default gateway. The default gateway here will be 10.0.0, let's say 254. Here it will be 20.0.0, 254. So first, this PC can only send to traffic to the same network. It goes to this address, which is a router. And router will take the traffic and put it into 20 interface, and it will come out here like this. So without the help of router, here is a 10.0.0.254. Here 20.0.0.254. This becomes the gateway address. So without the help of router, it is not possible for you to communicate between two different networks. See, more about routers and switches we'll be learning later. So this is also one of the important components. Also, we have some wireless devices we call access points, which will do both switching as well as routing job. When we go there, we'll talk about that. We have wireless protocols, 802.1, ABG standards, N standard, AC standard. Later, we'll see later. And there is also another component called firewall, very important, which will protect our network. Firewall also can do switching, routing. On top of that, it can do inspection.
Yeah.
You will have all.
So firewall is a software or like a physical device?
Software. We have physical firewall, which is hardware. We have all type of firewalls. And we also have cloud-based firewalls. Today, networking has grown very big, so we got in all flavors. Even routers, we have soft type, but don't get into those things in CCNA level. That you will see in industry as you grow. Otherwise, you will not learn that actually if you keep thinking about cloud and all. That's too much. Without knowing these things, talking about cloud is useless. Right? So let's not forget. So what we have covered today is we have covered this one completely, and some portion of this one, some of switching concept, and so on. So in our next class, we'll continue talking about these things. All right. So let us stop here. Do you have any question? Okay.
Actually, no. For today's class, I am clear. If I have any questions in my mind, then I'll just ping you in WhatsApp. Okay. Yeah. Next class.